The integration of this function is fairly straightforward using integration by parts. I'm going to just let the function, understanding that this is going to integrate as a sum and difference of two terms, both multiples of v, I'm going to look at the integral of dv over 1 minus av times 1 plus av, and that being the sum and difference of two terms. Okay, so we have the difference of two squares factors into the sum and the difference of the square roots of the two terms. And we'll correlate this back with the c over f v squared in a minute. But the expression we need to use partial fractions on is simply, the coefficient of dv in this integral, and that's 1 over av times 1 plus av. A is going to turn out to be the square root of c over f, but let's not worry about that. Now, I've unfortunately chosen to use an a here, and I'm going to use a big A here. So this is a little a, this is a big A. They're completely different variables. As we know from partial fractions, 1 over this quantity is going to be broken into a over the first binomial plus b over the second binomial. We place these over the common denominator, which is the product of the two denominators, and that's fairly easily done. We have 1 plus a times 1 plus av and b times 1 minus av over the denominator. This can be rearranged so that we have the a plus b term here and the a minus b term times little a times the v term here. It's important to break it up in this manner because this breaks the numerator of this expression into a constant and another constant multiplied by our variable v. Now, the numerator has only 1, so that this numerator has to always be equal to 1 no matter what the value of v. That tells us that a minus b times little a is going to be 0, because if it was anything but 0, then a change in v would cause a change in this numerator, and the numerator is constant. So first thing we know is a minus b is 0, and the second is that, and maybe the first, a plus b has to be 1, because of course this numerator has to be 1. If this term is 0, then what's left has to be equal to 1. So a plus b is 1, a minus b is 0. Our conclusion, a equals b, and comes from the second equation very easily. Plug that result back into the first equation, and we get a equals b equals 1/2. So that now the integral of dv over 1 minus av times 1 plus av is 1/2 times the integral of 1 over a minus, that should be 1. Let's just get rid of that step and write it again. So this equals 1/2 the integral of dv over 1 minus av and plus 1/2 the integral of dv over 1 plus av. That equals 1/2 times negative 1 over a, natural log of the absolute value of 1 minus av, plus 1/2 times 1 over a times the natural log of 1 plus av. And you might need to review integration by parts if you haven't already done so. This is a very common type of result, and these integrals are very commonly encountered, so this should be no big problem. But okay, that's how we're going to integrate this function. Now we're going to correlate this. A is going to turn out to be the square root of c over f, and going to be able to plug that in here, get this integral. Also note that this is going to equal, well, let's go ahead and do the one last step here. This is going to be 1/2 the natural log of the absolute value of 1 plus AV over 1 minus AV. Now, again, we're using the rules for combining logarithms, the rules of logarithms and exponents, which are inverse to each other. This is something that you encounter very commonly with integration by parts, so we're not going to spend a lot of time in this example worrying about why this is equal to this. This is something you should, if necessary, review.